Using a reduction formula, how do we evaluate integrals of this form? The integral of sine mx cos nx dx. So I want to evaluate the integral of sine cube x cos 4x dx. Here it contains sine and cosine. So I want to modify the integral to contain just sine terms only. That's what I want to do. The integral of sine cube x, then this is cos squared x all squared dx. You agree with me? Okay, so this is equal to, because 2 times 2 is 4. Remember in trigonometry that sine squared x plus cos squared x is equal to 1. So if I make cos squared x the subject of the formula, it means that cos squared x will be equal to 1 minus sine squared x. And that means that this is the integral of sine cube x. In place of cos squared x, I'll be writing 1 minus sine squared x all squared dx. And this is equal to the integral of sine cube x into, if I expand brackets, this is it. 1 squared is 1. 2 times 1 times sine squared x is minus 2 sine squared x. Then minus sine squared x all squared, that will be plus sine x all to the power of 4 dx. You can expand it, alright? You can prove that this is correct. This is just a shortcut to binomial expansion. Let's multiply this bracket with what's outside. So we have the integral of sine cube x. Now sine cube x times 1 is sine cube x. Sine cube x times minus 2 sine squared x. We have minus 2 sine x all to the power of 5. Then sine cube x times sine 4x, that will be sine 7x dx. So let me split this integral. I'll be having, this is 1, the integral of sine cube x dx, minus 2 into the integral of what? Sine 5x, then plus 7x, that is plus the integral of sine 7x dx. Now, we are good to go. I told you that we are reducing this integral into sine terms only, and that's what we have now. All of them are in terms of sine x. So whatever we get from evaluating this is what is equal to this particular integral. Okay. Now, in reduction formula 5, in the video reduction formula 5, we dealt with the integral of sine nx dx. And in reduction formula 4, you can check the videos, we dealt with the integral of cos nx dx. So, remember, if I sub n is equal to the integral of sine nx dx, we deduce the reduction formula for this, and we say that it is equal to negative 1 over n into sine n minus 1 of x cos x plus n minus 1 over n into I sub n minus 2. Yes, there is a video that shows this. If you watch the video on reduction formula 5, yes, 5, that's for this, you will see this. There's also a proof for the reduction formula for this particular integral. You can just check the videos. I think this is the 8th video on this series of reduction formula. So if I sub n is equal to this, and each of this integral is in this form, it therefore means that this entire stuff is equal to, this will be I3, because n is equal to 3. This will be minus 2 into I5, because n is equal to 5, plus this will be what? I7. So we are going to evaluate this. Whatever we get is what this integral is equal to. Now, what is I3? Let's start from I3. Using this reduction formula, I3, which is the integral of sine cube x dx, is simply minus 1 over 3 sine 3 minus 1 is 2, that's sine squared x cos x okay, plus 3 minus 1 is 2 over 3. 3 minus 2 is 1. What is I1? The integral of sine x dx. That is sine x to the power of 1. If you differentiate the sine function, you get the cosine. Integrate the sine function to get the negative cosine. So this is minus cos x plus c. It means that I3 will be equal to, in place of I1, I'll be writing minus cos x plus c. So this is simply minus 1 over 3 sine squared x cos x, okay, plus, this will be 2 over 3. In place of I1, I'm free to write minus cos x. So this is 2 over 3 times minus cos x, and that is actually minus 2 over 3 cos x plus the constant of integration. So this is our I3. What is I5? I5 is next. We can easily determine I5. Just watch. I5 is the integral of sine 5x dx, right? Based on this reduction formula, it will be minus 1 over 5 sine 4x cos x plus 4 over 5 I3, because 5 minus 2 is 3. So if we are to determine I3, I3 is everything we have here. We've determined it before. Now, I will not bother to determine I3 because we already have it. So our I5 is simply this. Minus 1 over 5 sine 4x cos x, okay, plus 4 over 5. Then I'll be writing I3, and that's I3. So let's go. This will be minus 1 over 3 sine squared x cos x, sine squared x cos x, okay, then minus 2 over 3 cos x. Then we add the constant of integration. All right, let's evaluate I5. Let's simplify it. Remember, we are determining this integral, okay, and we say that this integral is equal to I3 minus 2I5 plus I7. So we have gotten I3, we are simplifying I5 now, then we'll go to I7. So I5 is equal to minus 1 over 5 into the sine to the 4th power of x cos x. 4 over 5 times minus 1 over 3, that's minus 4 over 15. So minus 4 over 15. Then we have sine squared x cos x. Then 4 over 5 times minus 2 over 3. That's minus 8 over 15 cos x plus the constant of integration. Alright. So what will be I7? So remember, this is I sub n. That's for the integral of sine nx dx. So I7, using this same reduction formula, to be minus 1 over 7 sine 6x, 7 minus 1 is 6, sine 6x cos x plus 7 minus 1, that's 6 over 7, I sub 5. 7 minus 2 is 5. So we've gotten I5 already, right? This is I5. So let's substitute. I7 will be equal to this. Minus 1 over 7 sine 6x cos x plus 6 over 7. In place of I5, I'll be writing this. That will be minus 1 over 5 sine 4x cos x minus 4 over 15 sine squared x cos x minus 8 over 15 cos x, then plus the constant of integration. So let's expand. I7 will be equal to minus 1 over 7 sine 6x cos x. Okay, let's multiply 6 over 7 by minus 1 over 5. That will be minus 6 over 35, right? minus 6 over 35 sine 4x cos x, sine 4x cos x, then 6 over 7 times minus 4 over 15. What would that be? 6, this will be 3 here is 2, 3 here is 5. This is minus 8 over 35. So we have minus 8 over 35 into sine squared x cos x. Then lastly, 6 over 7 times minus 8 over 15. 3 here is 2 and 3 here is 5. So we'll be having minus 16 over 35. Minus 16 over 35 cos x. Then plus the constant of integration. This is I7. Remember, we are trying to evaluate this integral. Okay? And this is I3 minus 2I5 plus I7. We've gotten I3, we've gotten I5, and we've gotten I7. So what is I3 minus 2I5 plus I7? Let's evaluate that. I3 minus 2I5 plus I7 is this. This is I3 minus 1 over 3 sine squared x cos x minus 2 over 3 cos x. Then get the constant of integration. Minus 2 times I5. So I'll write minus 2. Then I5, everything here inside the bracket. Minus 1 over 5 sine 4x cos x. Then minus 4 over 15 sine squared x cos x. Minus 8 over 15 cos x. Close the bracket. Neglect the constant of integration. Then I7 is this. I'll add it plus I7 plus. Okay, since we are adding, I'll just write it the way it is. Since it is addition, plus times the signs that they have is still going to give us the signs that they have. So I'll just write minus 1 over 7 sine 6x cos x minus 6 over 35 sine 4x cos x minus 8 over 35 sine squared x cos x minus 16 over 35. So I will now add a constant of integration at the end of everything. Let's open that bracket. So this is simply minus 1 over 3 sine squared x cos x minus 2 over 3 cos x. Minus 2, we enter that bracket, we have my plus 2 over 5. Just follow me. This is a plus. Sine 4x cos x minus, okay, plus minus is a plus. 2 times 4 is 8 over 15 sine squared x cos x. Okay, minus 2 times minus 8 is plus 16 over 15 cos x minus 1 over 7 sine 6x cos x minus 6 over 35 sine 4x cos x minus 8 over 35 sine squared x cos x minus 16 over 35 cos x plus c. Okay, let's evaluate. Let me erase I5, I7. I have only one term in sine 6x cos x. So I'll write minus 1 over 7 sine 6x cos x. Okay, I have two terms in sine 4x cos x. This and this. So let me simplify their coefficients. 2 over 5 minus 6 over 35. What would that be? The LCM is 35, so we have 35. 7 times 2, 14, minus 6. That will be 8. 8 over 35. Okay, so it will be plus 8 over 35 sine 4x cos x sine 4x cos x. So I've dealt with this, I've dealt with this, I've dealt with this. Then I have powers involving sine squared x. How many of them? 1, 2, 3. Okay, that's sine squared x cos x. 1, 2, 3. Okay, so let me evaluate the coefficient. Minus 1 over 3, minus 1 over 3, plus 8 over 15. Okay, then minus 8 over 35. Minus 8 over 35. Let me do this one after the other since I'm not on my calculator. Okay, just quickly, let me take this first two. Minus 1 over 3 plus 8 over 15. This is 15. 5 minus 5. 1 times 8, that's 8. And that will give me 3 over 15, which is 1 over 5. So 1 over 5 plus, okay, minus 8 over 35 is 35. This is 7 times 1 is 7. This is 1 times 8. 8. So this is minus 1 over 35. Minus 1 over 35. Then I'm writing sine squared x cos x. Sine squared x cos x. Okay, so I'm done with this. I'm done with this. And I'm done with this. So what do I have left? Cos x terms. 1, 2, 3. So what are the coefficients? The coefficients are minus 2 over 3. Then we have 16 over 15, right? Yes. When doing problems like this, you have to be very, very careful because miscalculations can occur at some point. And then we have minus 16 over 35. Let me evaluate this first two. Minus 2 over 3 plus 16 over 15. The LCM is 15. 15 divided by 3 is 5 times minus 2 is minus 10. This will be 1 times 16 is 16. So this will be 6 over 15. And that is 2 here is 3 here is 2, 3 here is 5. That's 2 over 5. So this one is 2 over 5. Then I'll now say minus 16 over 35. You get what I'm doing? Okay. So the LCM is 35. 7 times 2 is 14. This will be 1 minus 16. So it will be minus 2 over 35, right? So everything here is minus 2 over 35. So I'll write my minus 2 over 35. Then cos x plus c. This is it. For this integral, the integral of sine cube x cos 4x dx, the integral is this. Minus 1 over 7 sine 6x cos x plus 8 over 35 sine x to the power of 4 cos x minus 1 over 35 sine squared x cos x minus 2 over 35 cos x plus the arbitrary constant of integration. This is it for this video, and this is it for reduction formulas of this form. I hope you've been following my series on reduction formula. Keep supporting by subscribing to this channel, like the video, and share it with your friends and your classmates. I'll see you in the next video. Just keep following.